Okay, so this video is again to help you understand how to solve systems of equations. And there's different methods. You could graph to find the point of intersection. You could also solve with linear combinations, elimination method, or you could also use substitution method. And sometimes certain methods are better than others. Right here, I would go with elimination method or linear combination, whatever you want to call it. So the first thing you need to ask yourself is, do you want to cancel out x's or do you want to cancel out y's? Now, in the thought process, like, I need this to be the exact opposite of this. So like, if this would have been a -4, then that would have worked. I could just multiply the top one by 2, right? Or if this were a +6, then I could multiply the bottom one by -2. But we need the same identical value, but one being positive and one being negative. So I need to change the 2 and the 3 to a certain number. And what number is that going to be? 6. Now you could have decided to change them both to 12 or to 24 or something that works with both 2 and 3. But the easiest number to change them both to is 6. How are you going to do that? You're going to multiply this top equation by 3. That way when you distribute 3 times 2x, that'll give you the 6x over here. And the bottom equation, let's distribute, change it by doing what? Multiplying by 2. So 2 times -3, that'll give you the -6. And now they're going to be able to cancel the x's, right? But you don't stop there. You have to modify the whole equation. So on the top, 3 times 2x is 6x. 3 times -3y is -9y. 3 times 5 is 15. The bottom equation, distribute the 2 all the way through. Yeah, we know that 2 times -3x is -6x. 2 times 5y is +10y. 2 times that -9, that's going to be a -18. So ladies and gentlemen, I have modified both equations to get the x's to cancel. Now, you might have decided to cancel out y's, which is totally fine. But the way I looked at it, when I looked at the 2 and the 3 and the 3 and the 5, I'd rather change the numbers to 6's than change these to 15's, right? I like smaller numbers instead of bigger numbers. But it would still give you the same answer. I mean, as long as you don't do any mistakes. So it's up to you if you want to cancel out x's or y's. Make a decision and modify the equations accordingly. Okay, so let's now combine the lines. That's why it's called linear combinations method. And we're going to eliminate the x's after modifying them. That's why it's also known as elimination method. And we end up with -9 plus 10, which is 1y, equals -3. 15 take away 18 is -3. So there's one answer right there. 1y equals -3. It's just y equals -3. I need my other answer. What do? Plug it in into any equation I want. I want to go with the top one. 2x minus 3y equals 5. Now notice that instead of y, I put parentheses. Why did I do that? Because y is really -3, and I'm going to put that -3 right in there into the y position into the parentheses. So my new equation becomes 2x plus 9 equals 5. All I need to do is subtract 9. Now we'll have 2x equaling -4. Final step will be to divide by 2 and divide by 2. So x equals -2. So our answer, on the next quiz or test that we take, I want you to go to the answer column and put the answer as a coordinate. X is -2, y is -3. If you put these numbers backwards, then it's technically wrong because this is the x, this is the y. So x is -2, goes first, y is -3, it goes second. Now there are some systems that don't have x and y. They might have an a and a b or a c and a d. Let's put it in alphabetical order. The C goes first, the D goes second. All right? Let's move on. You see, elimination method is not always the quickest method. I mean, sometimes they're set up for something easier. Now, if I wanted to do elimination method right here, I'd have to get my x over to the left side. I need to line it up. I need to get the x's on top of x's, y's on top of y's, equal on top of equal. And we should all know that, right? We could modify an equation and line them up. Then we could use elimination method. However, this is one that's kind of set up for substitution. Now, you don't have to use substitution, right? Maybe we should do both methods, substitution and elimination method, to compare. But anyways, right here I have y equals negative 2x plus 3. Some people might think, oh, that looks like y equals mx plus b, and they decide to start graphing this and see if it intersects at a nice point. But I wouldn't recommend that unless you have graph paper. Or some people will say, I have y equaling this stuff, so we could use substitution method and substitute this stuff into the equation we haven't used into what value, the x or the y? Into the y. And why is that? Because it says y equals. So I'm going to take this and plug it into the y, because that's what y equals. So let me rewrite my bottom equation. It's going to say x plus y equals 7. But instead of y, I'm plugging in that variable expression, negative 2x plus 3. This is what we call substitution. Okay? That's what we call substitution. Now we have an equation that we need to simplify. There is nothing to distribute. So you could just forget about the parentheses and have x plus negative 2x plus 3 equals 7. The x and the negative 2x will become negative 1x plus 3 equals 7. You'd have to subtract 3, so you end up with negative x equaling 4. So your final step would be to divide by negative 1, x equals negative 4. So far, our answer has a negative 4 in the x value. Now we need the y value, so we're just going to plug that in. I'm going to go with the top equation, which reads y equals negative 2x plus 3. And of course, that x value that we're plugging in is negative 4. So what's my y going to be? It's going to be y equals negative 2 times negative 4 is positive 8 plus 3, y equals 11. So my y value is 11, and there's my answer, negative 4, 11. So if I'm not too sure about this answer, I'm supposed to plug in the x of negative 4 and the y of 11 and see if it works for the top equation and the bottom equation. And it should. Now, what do you guys think of that substitution? If you don't like it, let's see if we could erase all this. Give me a second. Okay, so here's the same problem, but let me do it with the elimination method. So in order for you to use elimination method or linear combination method, they have to be lined up. X is on top of x's, y is on top of y's. This is not the case, so we need to move this around. Let's get the top equation with the x on the left with the y and having it equal a number 3. So I need to get rid of this minus 2. We're going to add 2x and add 2x. So my new top equation would be 2x plus y equals 3. My bottom equation is going to stay the same. X plus y equals 7. So now let's think, guys, linear combinations. If I combine the 2 and the 1, will it eliminate? No. How about the 1y with the 1y? No. 1y plus 1y is 2y. So what do I need to do? I need to modify one equation or maybe both equations to get something to cancel. What do you guys want to cancel, x's or y's? Y's. How do I do that? How do I cancel out the y's? Make one negative. So which one would you like to multiply by negative 1? The bottom one seems easy to multiply by negative 1. So my new equation, or my new system, is that right there. The top equation stayed exactly the same. I changed all these signs, giving us negative x minus y equals negative 7. So now we're able to combine the lines. The y's eliminate. 2 take away 1 is 1x. Bring down the equal sign, bring down negative 4. I have an answer. I need the other answer. All I do is plug it in. Y equals, I'm going with the top one up here, y equals negative 2x plus 3. And we know that the x value is really negative 4. That belongs right in there. So I have y equals 8 plus 3, which is 11. So y equals 11. Answer is negative 4, 11. It's the same problem, just done differently, right? Substitution method. Was it faster than what we just did right now? Kind of, right? Maybe not. I mean, I like elimination method all the time. The only time I'll ever consider substitution is if one equation already has y by itself, then you could substitute it into the other one and solve. So it's up to you. If you want to stick with elimination, go for it. So graphing seems to have not been that beneficial, but check this out. What if I told you to solve this system any method you'd like? Well, you might want to get the x's and the y's to the left side and do linear combinations, but aren't both of these equations already in slope-intercept form? Yeah. Now, you don't even have to graph this. Just look at those equations and visualize the lines. Where would they cross? 0, -2. Exactly. Why? Because both of these, they're both in y equals mx plus b form, and we know that they both have the same exact b value, right? I mean, you could even sketch this if you want. They're both going to cross right here. Oh, no, right there. Sorry. Here. So the top one, if you were to graph it in blue, it would go up 3 over 1, and you have that line. And the bottom one, if you graphed it in red, sketched it in red, it would go down 1 over 1, down 1 over 1. So they both cross right here at this location, which means that the answer to this system is 0, -2. So if they're both set up in slope-intercept form and it's obvious, I mean, you don't even need graph paper right here. You could see that both of them have the same b value. You know they're going to share that same point of intersection, and that point of intersection is 0, -2. If you wanted to, you could have lined it up. You could have done substitution. You could have done any other method, but right here, it really is best to think about the graph because you know that they both have the same b value. Now this one's interesting right here. Example number 4. It's already lined up. A's on top of A's, B's on top of B's, equal on top of equal, number on top of number. So let's go with linear combinations. What would you like to eliminate, the A's or the B's? A's definitely look easier because I could change this to a 10 and I could change this to a -10, right? Yep. But let's pause right here. Let's take a look at each of these equations really, one at a time. If I look at this top equation, there's nothing I could, like that's a 5, that's a 15. I wish that was a 25. Then that way I could divide everything by 5 and make it a little easier, but it's not a 25, it's a 24. But how about that bottom equation? 2a, 6, 28. I could technically divide, I could modify this whole equation by dividing it all by 2, right? Now, why would I do that? It might make things a little easier. Check it out. The top equation I'm going to leave the same. The bottom equation, I'm going to technically divide everything by 2, and I'll end up with a -1a, with a -3b, and with a 14. And now I could deal with this system right here instead of the original one, because this one's a little nicer, right? Now you could say, oh, I want to cancel out A's. Let me multiply the bottom one by 5, right? So let's multiply that bottom one by 5, put parentheses around the bottom one, multiply it by 5. Top one's going to stay the same. I'm going to leave it in the same color black. I'm going to write it down here. And the bottom one's going to change to blue. 5 times -a is -5a. That's great. It's going to cancel out the A's. But when we go 5 times -3b, that's -15b. And what? That's also going to cancel. All right, let's deal with it. And the last one, 5 times 14, that's 70. So when I do combine the lines, because I wanted the A's to cancel to eliminate, they do eliminate. But unfortunately, well, not unfortunately, but the B's also eliminate, which means I have nothing left on the left side. I have my equal sign, and I have 46 over here. So what do you guys think? Yeah, 0 equals 46. That's impossible. You say no solution. So you just put that as your answer, or you could actually write no solution. But the reason why I put this right here on our class opener is to recognize that sometimes when you look at an equation, if it's all divisible by 2, you might as well divide it all by 2, right? To make it look smaller, make it nicer. Let's take a look at another one. This one I had to handwrite because of the fractions. So what if you end up with this system? I know some of you are going to be like, oh, I don't want to do this. It has fractions in it. I give up. But the fact is, you could do anything you want to an equation as long as you multiply everything by it, right? So this top equation, I could make this look way nicer. Multiplying everything by 9. Now, if you multiplied by 3, it would get rid of this fraction and that fraction, but you still have a fraction here. Go with the biggest common multiple, right? Or the biggest common factor, which would be 9. So multiply everything by 9. I want to put parentheses around it with the 9 out here. That way I'll know, it's like notes to myself of how I'm actually going to modify this top equation. So when I go 9 times 1/3, that gives me 9/3, and 9/3, that's really like 9 divided by 3, which is 3 with an x. when I go 9 times negative 4/9, the 9 and the 9, they're going to cancel out, right? So I will just have negative 4y left over, negative 4y. And then 9 times 4/3, that's like having 9 times 4, that'll be 36, and then 36 divided by 3, right? Because on the bottom you have a 1 times 3, so you have 36 over 3, which is going to be 12. So I have equals 12. I did a lot of work in my head. I hope you guys understand it. But the point I want to do with this example is that it doesn't matter how ugly your equation is. You have a bunch of fractions, so what? Multiply everything by the denominator of the fraction that you want to get rid of, and you'll get rid of all fractions.
Why can't I just make it a decimal?
You could make them decimals, but by you doing this right here, the 3x, look at the bottom equation, 3x minus 4y equals 14, okay? We know that all we need to do is multiply one or the other by negative 1. That way we could get the x's to cancel, right? But to get those x's to cancel, everything ends up canceling. Well, at least the x's and the y's. So we have the same equation up on top, and we have our modified equation on the bottom. And when we combine, the x's cancel, the y's cancel, you end up with nothing, again equaling something, which we know is impossible. So again, we say no solution. All right, went over several examples, went over some special cases, went over certain questions that it's easier to use graphing instead of linear combinations. There's one question that was easier to use substitution instead of linear combinations, but linear combinations always works. Linear combinations, elimination method is all about modifying equations. You modify the equations to make it work for you. So right here, you didn't like the fractions, multiply everything by 9, you get rid of all fractions, right? You want something to cancel, modify an equation or maybe both equations to get something to cancel.